Hi, this is Benny. I've dedicated my life to understanding the universe in hopes that someday I am given the opportunity to hop on a rocket and see it for myself. Every atom in your body was created in a star. The carbon in your DNA, the oxygen you breathe, the calcium in your bones, all of it originated in stellar furnaces. This means that quite literally, the universe is in you. You are a product of cosmic alchemy, billions of years in the making. The same processes that formed galaxies also formed you, linking your existence to the vastness of the universe. Hello everyone, and welcome back to another episode of Space Bites. It's me, Benny, your favorite nerd. And today I'm back with Dylan to discuss quantum computers and the multiverse, reality or myth.
Hello. How's everyone doing today? Didn't really get enough of the physics world. Wanted to learn a little bit more from Banan. So, talk to me. What are we learning about today?
So today we're taking a break from our regularly scheduled programming to discuss something that has been all over the news lately, which is Google's new quantum chip. Okay, so before we go into the quantum computing world, I want to clarify a misconception. So I want you to go on your phone right now, and I want you to, on Google Images, look up the words quantum computers, and I want you to tell me what is the first thing that comes up when.
All right. So there's this movie that I watched called Eagle Eye, and there's just a bunch of like wires in the movie. Eagle Eye is like this, like it's starring like Shia LaBeouf from like 2007. It's like, as you can see, but the viewers can't. It's just like a bunch of wires and stuff. And in that movie Eagle Eye, that those wires and that quantum computer actually like kind of took on like an AGI type of mindset where they were able to just kind of like send text and like control like trains and stuff. It was actually like really not, it was such a dystopia, right? But that's the first thing I think of when I see that. It's so sci-fi. It's obviously that's the first thing I think of when I see that online.
Okay, so this is a misconception that I want to clear up. That's actually not a quantum computer. People will lie to you and tell you that it is. It is not. It is what we in the physics world call a dilution fridge. And each one of these shelves is just a way, it's like an extreme cooling system, right? Because to be able to, let's say, access the quantum world, you need to reach near zero temperatures, 0 Kelvin, not 0 Celsius or 0 Fahrenheit. But if you go down to the most bottom shelf, you'll find like a little blue thing, and there should be an image of that, and that's actually the quantum chip, and it just needs to be placed in like near cold, very very cold temperature. And so why does it need to be in really cold temperature? This is because quantum processors rely on fragile quantum states, and these need to be placed in really cold temperature so that heat and environmental noise don't disrupt these states, causing something called decoherence, which is the loss of quantum information. Okay, just putting that out there, just so you know, I don't want you thinking that that's a quantum computer. It's not. It's literally just a fridge. But that's not where we keep the ice cream. That's where we keep the quantum chips.
It's not where we keep the ice cream. Okay, that's good to know. Yeah. I was assuming they weren't keeping ice cream in there, but that's good to know. But yeah, no, I actually did some reading on quantum chips over the weekend because as you and I discussed a couple of days ago, the Google's new quantum chip, obviously, it was a big headline I saw on like Business Insider or TechCrunch, I'm not sure which one. But they released something that apparently the quantum chip believes that we live in multiple universes, which I'm not sure, how you could explain that. Obviously, for me, right, the first thing I think of is the sci-fi dystopia of a multiverse, right? But, I also understand a little bit of like the power that the quantum chip could have in like Web3 because of, what I'm doing for work. So would kind of like to hear your thoughts on how that multiverse theory or multiple universes theory actually works, if it's a real thing, and, just kind of go into some detail about that. That sounds like it would be pretty cool to know.
Okay, so before I go into the multiple universes theory, because that's in the quantum world, we just call that superposition, which is when things are allowed to exist in more than one state at a time. And I think that's what this AI chip is talking about. So not AI chip, what this quantum chip is talking about. But before I go into that, because that is quite detailed and it is a little bit, it's a complex topic to go into. Before all of that, I kind of want to go over the history of quantum mechanics. And for our listeners who, are hearing these words for the first time, I want to, sort of tell them where this idea originated from and where it all started. Does that
Okay,
sound
cool.
good?
Yeah, that sounds good. Let's learn.
So let's go back in time to the 20th century when scientists like Max Planck and Albert Einstein were trying to explain things that classical physics couldn't. Classical physics meaning like Newton's laws of motion. You know, the whole Newton story. He was sitting under a tree, apple fell on his head. He was like, ah, gravity.
Okay, word on the street is that's a myth. I've heard that. Is that true or is that false?
I've also heard that it is a myth. It might just be a way, like a fun way for people to be like, oh, like it hit, like the idea hit him in the head like an apple would. You know, like it
Yeah,
was just there, like bam.
I was gonna say there's no way that an apple just by chance hit this man, like one of the best physicists ever, like in his head while he's sitting under some random tree, you know?
Yeah. So classical physics couldn't explain something called the wave-particle duality. And this is the fact that light sometimes behaves like a particle and sometimes it behaves like a wave. And by the way, feel free to stop me at any time and ask me questions. That's fine. If you don't stop me, I'll just keep going and talking
Yeah.
and I'll never
I,
stop.
I was gonna say, what do you mean when you say that it can act like a particle or act like a wave? Can you like explain that to me a little bit more?
Yes, I was about to. So what does that mean? So they ran this experiment. It's called the double slit experiment, where they sent electrons through two holes, and sometimes these what you would expect to get is like a pattern of these electrons on the wall, but instead what also happened was an interference pattern, which is what you would expect if there was a wave. So what does this mean? It demonstrates particles like electrons change their behavior based on whether or not you are observing them. Okay?
So similar, is this kind of like a Schrodinger's cat scenario where they'll behave one way if you see it, but behave another if you don't?
Yeah, so that's where this sort of thought exercise originated from, just being like something can be in a superposition of states. So the cat could be dead or alive or sleeping or whatever, until it is being observed. Once you observe it, then it exists in one state. Okay?
For me, I don't. When I hear this story, like, obviously, like I've discussed and read about Schrodinger's cat a few times, but like, still to me, it's something that is. I don't know if it's abstract or not, but it's pretty unique because it's like just because you're observing something, that means it's only in that one spot. So does that mean that if it's not being observed, that it could be in a multitude of areas doing multitude of things at different times? Well,
Yes.
how does that exist, on the human plane, right? Like, does that mean that we're doing multiple things at once, like I don't know if metaphysically is the right word, but like metaphysically, like
Okay, so this how do you say principle of superposition of things being able to exist in more than one state at a time is a quantum mechanical property. It is not a classical mechanical property. We, as human beings, we exist where it's classical mechanics that are governing our world. It's, the classical laws of physics. It's not quantum mechanics. Quantum mechanics exists on very small scales and when it's super cold. That's why you need that dilution fridge to keep things very cold for quantum chips, because otherwise they will not behave that way. Does that make sense? So we're not quantum mechanical particles, we're human beings, But electrons, because they're so small, they exist in this, let's call it the quantum realm because it sounds really cool. And it just says that light can decide whether it wants to be a wave or a particle, but it's both depending on the situation. And I'm going to go into more detail. And then came Werner Heisenberg, Niels Bohr, and Erwin Schrödinger. And they were the ones who helped us understand the strange probabilistic world of subatomic particles. And it was Schrödinger's famous equation that described how particles like electrons can exist in many places at once until we measure them. This branch of physics gave us groundbreaking ideas like superposition and entanglement, both of which are crucial to quantum computing. And, they laid the foundation for that. And now that we know where it all started, we can dive into Willow, which is Google's new quantum chip.
let's do it. Let's dive right in head first. Let's go for a swim.
So do you know how regular computers work? And this is based on bits, zeros or ones, like tiny switches. So everything that your computer does, emails, videos, apps, is based on these zeros and ones.
Yeah, that makes sense to me.
So quantum computers work using something called qubits. Again, just adding the word quantum before everything to make it sound really cool. And what makes qubits so special is that they can be zero, one, or both at the same time. And again, we're going back to this idea of of superposition of states. Let's use a metaphor because I like metaphors. It's like flipping a coin and having it land on both heads and tails. So you flip a coin, you would expect it to be either heads or tails. This is in the classical realm. This is in the world that we live in. But quantum mechanics tells us you flip a coin, you can have both heads and tails at the same time.
Interesting. So in smaller and more like minute, not minute, because I don't think it's minute. I think saying minute makes it sound like it's less important, but like in more minute and smaller scales of like life that we live in and how we observe it, things aren't like it can be both at once. Is that what you're saying?
Very, 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 very small scales, yes.
Yeah. Like very micro, very micro.
Yes.
Okay.
So the way that a classical computer works is, okay, imagine there's a maze, right? And you have a classical computer and you have a quantum computer, and you're trying to get both of them to walk through this maze step by step. A classical computer will walk through this maze one step at a time. It will go through it, one step at a time. It takes it step by step. A quantum computer explores all possible paths at once to find the best route possible. That's what makes it so much faster, so much more efficient.
I was gonna say, is that what makes it like exponentially faster and why like quantum chips and quantum computers are supposed to be like the future and like it's kind of like a race to get there first?
Yeah, because imagine the different possible things that we can get done when we are no longer being held back by the fact that we have to take things one step at a time. We can go through all possible solutions, all possible routes, all at the same time. So instead of taking 10 different paths, we take one path to get to the same result in less time. So it's more efficient.
Okay, that makes sense. Do you think there could be an ethical like thing to consider when looking at the quantum computers and how, because they're going to be so powerful, kind of whoever has the earliest and the most broad access to them could be at a significant advantage, whether it's economically, socioeconomically, politically throughout the world.
Yeah, so based on what I read, first of all, quantum computers are, we don't expect them to be commercialized until early 2030s. We're not expecting it to be ready anytime soon. That's the first thing. The second thing, however, I'm pretty sure, if I'm not mistaken, I read that your data, Apple, it encrypts your data better on iMessages, and it makes it like quantum proof so that even quantum computers cannot access your data, because that has been a worry that these supercomputers will be able to access information a lot more easily, and all of this encryption that we have around our information and around our privacy is at risk. So something that we can sort of read up on later is, what are all these big tech companies like Apple and Google doing to protect our information in this new era of supercomputers, quantum computers that can do so much faster? So there definitely is a little bit of an ethical issue there, yes.
Interesting. Because what I've heard is that, like, for example, I was reading a couple of days ago that, in order to not have your texts able to be seen, you should use WhatsApp because WhatsApp encrypts them in a way that the data isn't able to be seen. But I think I've read that iMessage has that fault in their system right now.
Yeah, I think that's something that Apple needs to work on for sure.
Okay, that's
So,
good to know.
so what other than superposition makes these quantum computers really special? And this is another really cool concept called entanglement. And this is where things get really funky. So qubits, which are, these, zeros or ones that make up the computer, can be connected in a way that their outcomes depend on each other, even if they're far apart. So it's like, have you ever played with dominoes and when you set them up and you let one fall and everything else falls? So it's like playing with dominoes, and you get them to, one of them falls because the one before it fell as well, but they're super far away from each other. So you've got a domino in Durham, you've got a domino in Jeddah, you've got a domino in Rhode Island, but somehow these dominoes are all connected. They're being affected by the other dominoes' behavior, even though there's so much distance between them.
Okay.
That's what entanglement is. Yeah.
Interesting. Yeah, I mean that makes quite a bit of sense. Go ahead. Continue.
It is also like a pair of magic dice. If you roll one, then the other one instantly shows the same result. Or having two coins in different rooms, and if you flip one and it lands on heads, then the other one instantly lands on tails, no matter the distance between them. And Einstein called this spooky action at a distance, and it's a key feature of quantum computing. It's like having a pair of gloves in two separate boxes. Open one box to find a left-hand glove, and you instantly know the other box has the right-hand glove, no matter how far apart the boxes are. So it doesn't mean that it doesn't necessarily mean that the glove was always the left-hand glove. The glove could have existed in a superposition of states, meaning it could have been the left-hand glove or the right-hand glove, but upon being observed, upon you opening that drawer, it becomes the left-hand glove. Quantum entanglement tells the other glove to exist as the right-hand glove. Am I starting to sort of like paint a picture for you in
Yeah,
your head?
it's like quantum entanglement kind of gives you like instantaneous connection across like any distance pretty much. That's what you're saying, right? And I think like I wonder if in a way to explain that you could explain how like going to a place like Durham and having friends who are so like dispersed throughout the world, there is some sort of like quantum entanglement that gives you the connection to keep up with them. Is that like a good way that I'm able to describe it? It's like quantum entanglement, no matter where the particles are, no matter the distance of them, they're able to stay connected just the same way that people who are scattered across the world are.
Yes, of course. And it's saying that it's almost as if, let's say you and your friends, you got friends all over the world, you and your friends are able to stay connected and communicate without actually being connected, if that makes sense. You
Yeah.
just know that based on whatever state you're in, then your friend is also in either the same or the opposite state.
Okay. That I think I get what you're saying there.
Does it
And
make
I'm curious, when you say the same state or the opposite state, what do you mean by that? Like, how could you explain that in people terms based on the dialogue we just had?
so the way I'd explain it is, like I said, if you have a coin and you flip that coin, let's say that coin lands on heads, then it would instantaneously communicate with the other coin to either land on heads or tails, either the opposite or the same. The opposite being, opposite state.
So it's literally like a Schrodinger's cat scenario, right? Where, because I'm in London right now, right? You know, if one of my friends in New York calls me, or if one of my friends in New York is communicating with me, it's either I'm in New York or I'm in the place with them or I'm in London. But no matter what, there is still that instant connection, no matter that distance. It just depends where I'm being observed from.
I guess you can put it like, yeah, I understand now what you're trying to get at. Yeah, I guess you can put it in that sense. Yes.
I'm trying to put it into like layman's terms and like relate it to something in my life that I can describe it with.
But like I said, there's like the gloves example, there's the coins example. Is that not something that you feel like makes it easier to understand?
I feel like it makes it easier to understand, but it's too. I mean,
Abstract.
I'm an abstract thinker. I'm a colorful thinker, but like I think that having a coin in heads and tails is still something that I'm trying to wrap my head around. But I think the way that we just spoke about it makes it a little bit easier for me to understand.
So in the case of the computer, it would be like saying, you know how we said qubits, zeros and ones, right? This is what makes up a computer. It's like saying if you have a zero and you have a one, these two are entangled. If you have the first, let's say qubit is a zero, it tells the other qubit to either also be a zero or be a one, and they're able to communicate because they're particles, and they don't necessarily need to be, connected in any way. And the way that it is able to tell the other qubit to be either zero or one is because that qubit is in a superposition of states. It's already a zero and a one at the same time. It is just waiting for the other qubit to communicate to it and be like, be a zero, be a one, based on what that first qubit is. What state is it in?
Okay. Okay. Yeah. I think I get to know.
Okay. So two things make Willow special, even compared to other quantum computers. And the first one is error correction. And this is on, I'll post the link to the to Google's website where they talk about Willow. The first thing is that Willow has been able to reduce errors exponentially as you increase the number of qubits, right? So qubits are super sensitive and errors can creep in. And what's cool about Willow is that it's designed to fix these errors automatically, kind of like having a built-in spell checker. And here's the incredible part: as you increase the number of qubits in Willow, the error rate actually decreases. And this is thanks to an advanced technique called quantum error correction. Willow uses extra qubits to detect and correct errors without disrupting the quantum information. So it's like having a team of editors that are constantly proofreading and editing your work as you write it so that it ensures the final result is flawless. And this innovation significantly reduces the chances of computational mistakes.
That'll be huge. So I think like, after doing a little bit of research on it myself, I think two things that it'll be really big for are one, the future of how, I mean, just all software development in general will work because it can reduce the mistakes in the coding. And then also, given like what we're trying to do at Two Ticks, I think, the data security and like the cryptography, I guess, to prevent fraud will be huge in like the Web3 blockchain world. I think that will probably be huge, especially because it's such a new space. So that those sound like places where, Willow would be huge. Obviously, we're mentioning like we're waiting on the development of it and like how it's not going to be commercially available for a while. But I wonder how much of an advantage it also gives Google to create kind of anything they want to create, or if it could be even open source, Willow. But unlikely, I think.
What do you mean create whatever they want to create? Like what, as a creative person or as a business guy, what kind
Well,
of possibilities
you
do you see?
you say like you're seeing like how like we're talking about how powerful the computer is, the quantum chip is, right? Like those tools not being publicly available, it's kind of like how democratizing how Spotify changed the music industry, right? The streaming service was the most powerful tool to democratize the music industry, you know? So the quantum chip is probably going to be something that once publicly available makes everything a lot more accessible to create. But as of now, given that it's only in a few people's hands, like how music was in like the early 2000s, that select group of people are going to be able to kind of put that in a way like how music was only in certain people's hands. It became their decision, who they wanted to push to the radio, and it became a lot more profitable for a very specific sector. Where so for that specific sector of people, the record labels and the executives, right? So I'm curious if, with Google having a quantum chip, they'll have the ability to kind of develop certain type of software that maybe, like OpenAI might not be able to, or that Facebook might not be able to, or Apple. So I think that's something that we should also keep an eye on because it's like they have the most powerful tool in software development right now. And I think that will be huge. And of course, they're not using it solely to focus on the software, but I think that if they have this advantage, they'll be able to to cross new boundaries that, some companies might not even be thinking about right now.
I agree. And there's definitely the question of should one company have access to so much? You know what I mean? Because we do need their resources, their money, their whatever to develop this in the first place. And this is what they're doing at Google, right? And the guy who's in charge of all of this, Hartmut Nevin, he even had this one TED talk where he talks about all of this, and it's super interesting. But it also begs the question: once they're done developing this, like you said, how democratized is it going to be? Are people going to have access to it? What, are there military uses to this? How is it going to be, ethical issues? So definitely a lot of things do come up from this. I agree.
Yeah. I mean, it kind of gives me a similar vibe, but not the same vibe as like, how OpenAI has kind of now turned ChatGPT into a for-profit company, which has obviously had a lot of controversy in the public eye. Um, because originally OpenAI was supposed to be a tool that, was for everyone, that's hence the name OpenAI. But then, just due to philosophical ideas, changes, stuff like that, they're now going for profit. And it's like, originally OpenAI was supposed to be this, open source for everyone. And now, again, like you do need to maintain funds, so of course it makes sense for them to do that as a business, right? But it's also like, if Google has the most powerful quantum chip and then OpenAI then has, the most powerful AGI, right? It's like it's gonna be hyper focused pockets of, corporations or people that have access to these tools, and it'll likely become very expensive. So it'll be harder there'll be a bigger barrier of entry, I think, to get these tools. And if you have these tools, you're on a much different playing field, I think, when you're creating something now in the software or tech world. So I don't know, I think that's something that we should think about and definitely be aware of as like these super technologies that are completely different kind of enter our marketplaces and enter our public domain.
I agree. And like a little bit of a more optimistic perspective on all of this is it is very cool to live in a world where we get to witness all of these dramatic changes. You know what I mean? It is very cool. Even cooler to be able to sort of like step back and really get into how these things work. Like I'm sure when you initially heard the words quantum computers, it might have sounded like the super complex thing, but when you really get down to it, you realize it's just these particles behaving in whatever way they want to behave in, and sort of coming wrapping up this quantum computing thing. I wanted to mention like the second thing that Willow has been able to do that's different to other quantum computers, and that it has been able to perform a standard benchmark computation in under 5 minutes that would take one of today's fastest supercomputers 10 septillion years. Yeah, that is 10 to the power of 25 years. That vastly exceeds the age of the universe.
So we're gonna see exponential shifts in the way we live our lives then with these quantum chips. And again, like you said, I do think it's incredibly cool that we live during this time. I mean, we live during the most innovative and explorative time in human history, And I felt like I did get maybe a little too pessimistic during my last like minute of talking, but like it's kind of like I think that yeah, even though there is those ethical questions, it's also these companies are the ones who have created these things, so it is up completely their domain to choose what they want to do with it. Obviously, hopefully it doesn't get to a point where it's bad, but like, it's their right. I guess maybe they're bored and their shareholders may have something to disagree with it, but it's their prerogative.
It is very cool. I agree. And I think it's fine to be pessimistic, especially when it comes to technology. I think it's better to be critical of something and then reap the rewards and enjoy them rather than, approaching something at face value. But that is all the time that we have for today. I hope that you enjoyed today's sort of delve into quantum mechanics and the quantum world and how do these crazy particles act.
Yeah, it's been
Yeah.
super cool to learn. I think my only question will be, are we living in the multiverse for the fans out there? Are we living in the multiverse, Because Willow says we're in multiple universes, and that's obviously just a headline, but after learning all this, are we in the Marvel multiverse? Are we in the Spider-Man multiverse? Or are we just in a normal multiverse where things are moving and they're only, it's considered a multiverse because of the Schrodinger's cat theory, as we mentioned, that because when something's observed, it's in a different state than if it's not being observed.
So no, I don't think the Willow quantum chip has said anything about us being in a multiverse. I think there has been a confusion on analogies used when describing quantum computing. So the question is connected to this idea in quantum physics called the many worlds interpretation of quantum mechanics. And the idea of the multiverse comes from this many worlds interpretation, MWI, of quantum mechanics. And what does it mean? It means every time a quantum system is measured, the universe branches into multiple realities, with each outcome of the measurement realized in its own universe. And again, this is all theoretical. Obviously, none of this has been proven. And because of this idea, it suggests a vast multiverse where every possibility exists. So this is where this analogy comes from. And it's also from the fact that in quantum mechanics, we have this idea of superposition where things can exist in more than one state at a single time.
If the size of the solar system is your hand, so if the sun is at the center and these are the planets, then just our Milky Way galaxy is the size of the North American continent. And that is just our galaxy. We have been able to observe thousands of galaxies The world is very large. Anything is possible. And that is the beauty of physics. And that is the beauty of learning about our universe.
Amazing. Banana Yamani, you have just blown my mind today. I feel like I've learned a little bit. Every podcast, there's got to be one mind-blowing thing, and I think really kind of picturing how big our universe is important to that. So thank you for teaching me all this. I've had a wonderful time today, Banana, and I'm excited to learn more the next time that you invite me on.
So, if you enjoyed this podcast and if you enjoyed today's episode, then please don't forget to follow this account and hit the little bell button to ensure that you stay updated and you're informed every time I post a new episode. Thank you for listening, and I hope you've had a good time.